Okay, well, hi everyone. My name is Laura Acosta, and I'm the project manager for this Capstone Experience team, and my teammates are
Kate Burrows,
Joseph Cummings IV,
Tate Thornley,
and Xander Smith.
and we're working with ABF Freight to reduce the empty cost of Relocube repositioning through forecasting and optimization. I would like to say a huge thank you to Jacob Hofstetler, the lead financial analyst, and Kirby Clark, the direction of financial planning and analysis, for working with us throughout this whole year and just supporting us. Now, Jacob, I'll pass it on to you if you'd like to say some words.
Yeah, thank you. My name is Jacob. I represent ABF Freight. This year, we're able to work with Laura and Xander and their team. We pointed the team to an issue which tends to plague our industry, the cost incurred from repositioning equipment, having the right equipment in the right place at the right time. We asked for their help in developing solutions from an engineering perspective. A major benefit of participating in the Capstone program is the access that we gain to leading edge methodologies used by engineers and academia to help solve our problems. With this in mind, we asked the team to be creative in their solutions, and we're excited for them to describe their process and results today. Just wanted to say thank you again for all your efforts and looking forward to this.
Yeah, thank you, Jacob. So yeah, like Jacob said, we're working with the Relocubes and just trying to reduce the empty costs that are associated when we reposition those cubes. And now Kate is going to tell you more about our industry partner.
Thanks, Laura. Yeah, so as mentioned before, multiple times, we have been working with ABF Freight for the past several months. Just a little bit of the background about ABF Freight is that ABF Freight is a subsidiary of ArcBest. ArcBest has other subsidiaries, including Panther Premium Logistics, ArcBest Technologies, ArcBest Freight Logistics, and FleetNet America. But our industry partner, ABF Freight, is positioned in large markets where customers do not have to order by the pallet or talk to multiple representatives. So one critical function of ABF Freight is their LTL shipments, where the customers of ABF Freight are not required to ship their belongings by any minimum amount. So the services that they request are obtained upon purchase. And a lot of this information has been gathered from the ArcBest website, as well as from Jacob and Kirby in various stakeholder meetings. So moving towards our current project, our team in regards to ABF Freight was assigned to the financial analysis department. And the task at hand was learning how to allocate these Relocubes in ABF Freight's UPAC service in various parts of the country, while simultaneously satisfying customer demands. So Tate's going to explain a little bit more in depth about the project as a whole and the UPAC system.
Thank you, Kate. So after stakeholder interviews with Jacob and Kirby, we determined that the system of interest that we would be focusing on is the UPAC service they offer. UPAC is a self-move service that allows customers to take control of their move by packing exactly how they need. There's no need to wait for a crew. So as mentioned before, UPAC offers two distinct services. The first one utilizes Relocubes, as you can see on the left right there. It's a portable container that is brought to your home. You load it, lock it, and then it's picked up and delivered to your new home. The second option is the moving trailer, which you can see on the right. It is a 28-foot trailer that is delivered to your home with a ramp. And similar with the Relocube, you load it, lock it, and it is picked up and delivered to your new home. UPAC is a very simple process, as you can see in the kind of flow diagram above. The process begins with just setting a drop-off date, location, and arranging for safe and legal parking, whether that be in your neighborhood or your apartment complex. And then next, ABF Freight will deliver the needed equipment, depending on the selected service, to your home. You then pack your belongings in either the Relocube or the moving trailer and secure them for transit. And ABF Freight allows up to 3 business days for this, so there's no need to rush. And then once you're finished loading, just notify ABF Freight and they will retrieve the equipment from your location to either be relocated to your new home or to a secure ArcBest service center for storage if that's the case. And then all that's left to do is unload your belongings at your new destination, and then ABF Freight will come pick up the equipment. And like I said, this information came from stakeholder interviews with our industry partner and from the ABF Freight website. The pricing for each service depends on the service you use. The Relocube containers are priced at a per container rate, while the moving trailer pricing is based on the linear footage you use of the trailer. So with the moving trailer, the less space you use, the less it actually costs you to move. And the equipment needed for each service also varies depending on the service you use. The Relocube requires a special all-terrain forklift and a special flatbed trailer for delivery and removal. And the moving trailer comes with a bulkhead, which allows for the isolation of household equipment in the trailer. And the reason for this is because if the customer doesn't use all the space of the trailer, the extra room can be used by ABF Freight to transport freight of their own to the same service center as the customers move. And the hopes of this, doing this is reducing the likelihood of that unused space. And then it's fair to mention that during the course of our projects, we kind of had a shift in focus that was decided by my team and ABF Freight that we would mainly be focusing on the Relocube aspect of the UPAC service. And then up next, Xander's going to talk about ABF Freight's main areas of concern.
Thanks, Tate. So in stakeholder interviews with Jacob Huffstetler and Kirby Clark, we found out that currently ABF Freight's main area of concern is related to repositioning and the empty costs that are associated with that repositioning. So UPAC is a service that's offered countrywide, and they need their equipment at different places and at different times. And one thing with ABF Freight is that they really desire 100% customer satisfaction. So that means that they're going to move their equipment to meet customer demand and just adjust their rates accordingly. And then when they can move their equipment to meet demand, that's when these empty costs are incurred because the Relocube is transported without any value on board at the expense of ABF Freight. So to kind of explain this problem a little better, you can look at the graphic that we have on the screen. And if you look under the graphic, you're going to see that we have a high demand service center and a low demand service center. So for the purpose of the graphic, we made an assumption that a high demand service center is at a shortage of Relocubes and a low demand service center is at a surplus. So the high demand service center will request Relocubes from the low demand service center. The low demand service center will send the Relocubes, and it is during this movement that these empty costs are incurred. So once the Relocubes arrive at the high demand service center, the customer is able to load their belongings into the Relocube and send it out to the final destination where they're moving to. This part of the move is highly valuable as the customer is actually paying for the move because their belongings are in the Relocubes. So currently ABF Freight does not have a model that can forecast where the Relocubes need to be positioned throughout the year. So next, Laura's going to tell you a little bit about the data analysis our team performed to assess the system performance.
Thank you, Xander. So ABF Freight provided us with two databases, the transactional database and a Relocube movement database. The transactional database basically tells the interactions between the customers and the service centers, while the Relocube movement database tells the interactions between the service centers. So whether they ship the Relocubes and whether they're empty and loaded the same as when they receive it. In the transactional database, they also provide us with a distance matrix where they let us know the distance in miles between all of the service centers, and that later helped us, and we used that in our optimization model. They provided us with 5 years of data from 2016 to 2020, and we use this using SQL queries to also later find out our forecasting demand and other things for our optimization model. Up next, Joe is going to tell you more how we use these databases to get our performance measures.
There are two main performance measures to assess the UPAC system. The first is the empty Relocube utilization percentage, and this percentage is the percentage of Relocubes that are empty while traveling between service centers. It is found by dividing the number of empty Relocubes in transit by the total number of Relocubes in transit. And the second of our performance measures is the allocated empty miles between service centers. And this is just the number of miles between two service centers to meet customer demand. And it is found by subtracting the number of miles Relocubes are loaded with customer belongings from the total miles. The current issue that we have at hand is that ABF Freight incurs costs whenever customers do not utilize a full space within a Relocube. But what we found from stakeholder interviews with Jacob Huffstetler and Kirby Clark is that a % would be best to represent the amount of space that a Relocube occupies within a trailer. And what we found, or in order to find this, we basically divide the 6 cubic feet that a Relocube contains by the space offered by two 28-foot trailers. This is then multiplied by the number of Relocubes that are contained within one trailer. It's also important to note that whenever we are transporting Relocubes, there will always be 2 trailers per truck. from the per percent, we can find the total allocated miles. And these are the number of miles Relocubes travel while loaded. And this is just the sum of the per percent times the number of miles traveled over time. The total allocated miles then allows us to find the total allocated empty miles percent. And this percent is used to compare back to the Relocube utilization percentage to see how well ABF is at repositioning. And this is found by dividing the total allocated empty miles by the total allocated miles. What we found in 2020 is that 9% of the moves traveled by ABF Freight were empty compared to the total 17% of moves that occurred. Now moving on, I will go a little bit more into the Relocube tracker model and a little bit of the swim lane diagram that was used to create it. In order to assess like the UPAC system, we wanted to see how the flow of Relocubes worked throughout the system. In order to identify those movements, we created the swim lane diagram. Or basically the swim line diagram begins where a customer places the order and ABF Freight has to meet that demand with their supply. In order to do this, a Relocube will either have to be at the location that that customer reached out to, or that Relocube is gained from another service center location, where then that customer has the option of either loading it at the dock or at their preferred location. Once it's been loaded, that customer then has the option of either loading it at another destination location that they want to, or at a destination service center, where that Relocube will eventually be unloaded or either stored, and then eventually it will end up at a destination service center. In order to create this, or what we found from this was 10 main events, and from there we were able to create 7 variables. And in order to create that, we had to work extensively with Dr. Exioglu, and those 7 variables were implemented within Visual Basic application. Next, Laura will talk a little bit more about those 7 variables.
Thank you, Joe. So like Doug mentioned, our Relocube tracker was implemented in Excel and VBA. And we used the 10 variables to basically figure out how is the system going to react to this specific events. So our variables are divided between the transactional database and the Relocube movement database. The variables that refer to the transactional database are variables J, K, I, and F, as you can see in the left. Variables J and K just represent the new empty Relocubes at a service center and the new loaded Relocubes at a service center, while variables I and F represent the Relocubes at a customer location and whether they're being loaded or unloaded. The reason that we wanted to know this is because we wanted to see if a Relocube could potentially be emptied up within that week after it's unloaded by the customer. Now, the variables that refer to the Relocube movement database are variables D, E, and B. Variables D and E represent the empty Relocubes in transit to the destination service center or the loaded Relocubes in transit to a destination service center. And finally, variable B represents just basically the new empty Relocubes that are entering a service center. And the reason we wanted to know this one is because we wanted to see which service center were receiving empty Relocubes and how many were they receiving per week. So to the left is an example of one of our 10 events. This event refers to the Relocube movement database, and this just represents when an empty Relocubes is in transit to a destination service center. So as you can see in week 1 in service center 1, variable D is added with the number of Relocubes, and it's subtracted from variable J because that is the one that keeps track of how many empty Relocubes they have at a service center. And then in part 2, you can see when the Relocube was delivered empty, it's added to variable B. That's the one that keeps track of new empty Relocubes entering. And variable J, since that's also the one that keeps track of the Relocubes. And so we decided to do the Relocube movement tracker in BBA, and like Joe said, Dr. Iholu was really helping us make the Relocube effective, separated into 2 files and just work with the arrays and create this inventory per week. Up next, Kate is going to tell you more about our forecasting tool.
Thanks, Laura. So while we were creating this Relocube tracker model, we also, with help from Dr. Chimka and Dr. Liu, began developing a forecasting tool to help ABF Freight better allocate their Relocubes. So the first thing we did is we began filtering the transactional data instead of a yearly basis onto a weekly basis for each service center. And from this, we were able to generate some statistics such as the demand of these Relocubes, the standard deviation, and also the upper and lower bounds. So these numbers were based off of the previous 5 years of data that ABF Freight supplied with us with. And by obtaining these, we were able to offer ABF Freight a detailed table of how many Relocubes they should expect on a weekly basis at each of their service centers across the country. So as you can see in this table on the screen, this graph shows the forecasted demand for Service Center 380. And this is ABF Freight's most popular service center. So as you can see, the demand prediction follows the seasonal patterns that we've mentioned before, with the dark green line representing the demand prediction on a weekly basis, and then the red dotted line, which is the most accurate of the predictions, is the moving average, and then the upper and lower bounds are in light blue and gray respectively. So we found technically that there's no true way to predict how many Relocubes will be needed at any given time. And this is due to the fact of those seasonal patterns that we've talked about. And overall, there is just a random process based on customer needs. So a limitation in regards to this is that the forecasting model is based on weekly numbers. And if ABF Freight were to add more years of data, this could potentially make the forecasting tool more accurate. Tate's going to talk a little bit more about the error testing that we did on the forecasting model.
Thank you, Kate. So after we created the forecasting tool for the inbound and outbound service centers on a weekly basis, like Kate just explained, we were able to get a better understanding of the needs of each service center. Then from this, we decided to run another type of forecasting as well, with the first model being the one that Kate just explained in the previous slide, that took into account previous years of data to provide us averages and upper bounds and lower bounds and give us an idea of each service center's usage level. The second model we generated using the Excel forecasting, which only takes into account the previous 3 weeks of data and only forecasts 6 weeks in advance. And as mentioned before, ABF Freight's very seasonal, or their UPAC service is a very seasonal business. So that had to be taken into account when running both of these forecasts. And we found that the first method, our own method, generated more accurate results when we performed our error checking due to the fact that it takes in multiple years of data and not just the previous weeks. And to test how accurate the demand was for these two types of forecasts, we used 3 different error checking tests, the MSE, MAPE, and the RMSE. The results of the MSE and the MAPE are specified by week so that we can detect the outliers a little more easily. And the RMSE test results give the results as overall for the predicted weeks. The graphs below represent the historical data forecasting. As you can see with the graph on the left, you can see outliers between weeks 17 to 20. And with the graph on the right, we observed the results of the 3 tests after eliminating the outliers, and the accuracy of the model increased, as well as the value of the test decreases, which is a good thing. The accuracy and predictions are based on each service center separately and not for all the service centers together, just because they're also different. So that had to be taken into account as well. And then my team and I would like to extend a big thank you to Dr. Liu and Dr. Chimka for their assistance and knowledge in the development of the forecasting tool. And then I'm now going to introduce the optimization model that we have developed. So once we completed our forecasts, the next step naturally was to develop an optimization model in order to improve the system, which has been the goal this entire since we started working with ABF Freight. The decision variables and parameters we used can be seen below. The decision variables can be seen in the purple boxes, and the parameters can be seen in the red boxes. First, we have Y, which represents the number of empty Relocubes sent from one service center to another. Next, we have I, which refers to the number of Relocubes kept in inventory at the service centers. And then next, we have I as a constraint, which is the initial inventory of Relocubes in the origin service center. Then we have L, which is the distance between service centers. Then we have S, which signifies the supply available at each service center. And then finally, we have D, which just refers to the forecasted demand for each service center that we generated from the Excel forecasting tool. And the next step, Xander is going to go into a little more detail about the optimization model and how it can be used to improve the system.
Thanks, Tate. So once we've defined our decision variables and the parameters, we can then write the constraints. So after conversations with Dr. Relocube and Dr. Sullivan, we decided that our optimization model fits well with a combination of both a transportation model and an inventory model. So based on that, we moved on to make these 2 constraints. So this first constraint is called an inventory balance constraint. And so what this constraint does is it ensures that the previous week's inventory plus the supply, and supply is the number of Relocubes we expect to be free in the upcoming week based on a transaction becoming complete. So the previous week's inventory plus the supply subtracted by the demand or the Relocubes leaving a service center. We then also need to make sure we account for any Relocubes that leave the service center or enter a service center. And so the inventory balance constraint, if they're leaving a service center, subtracts those Relocubes from the week's inventory. And if they're coming into a service center, we'll add those Relocubes into inventory. Our other constraint is an initial inventory constraint, which basically initializes the initial inventory at the beginning of that planning period. And we'll talk about that a little bit more in the next slide. But lastly, our objective function is to minimize the repositioning costs within the UPAC network. So if you look on the equation underneath the objective function, we're mostly focused on the left-hand side. And what this is saying is you take the number of Relocubes that are being, you take the summation of the number of Relocubes being sent between service centers I and J in week W, and you multiply them by the distance between those service centers. You then take that summation and you multiply by the costs to transport an empty Relocube per mile, and that is what we're trying to minimize. So next, Kate's going to talk a little bit about how we decided where our team is going to initialize initial inventory for our model.
Thanks, Xander. So this chart, as you can see, represents the most popular service centers that ABF Freight has. So what we defined as the most popular is the outbound service centers that have the most Relocubes coming out of them. And from the two databases, we found how many empty and loaded Relocubes ABF Freight has each week in general. So based on this information, we were able to calculate the initial inventory. So to calculate this initial inventory of each outbound service center, we multiplied the number of empty Relocubes available weekly by each service center's popularity weight. And since this graph shows only the most popular service centers, it is important to note that some service centers could be multiplied by 0, meaning that they are either insignificant by the least amount of popularity or they're insignificant by the least amount of available Relocubes. Ultimately, we found that because ABF Freight does not provide initial inventory, this calculation isn't the most accurate, but it still contributes to the overall model and is included in our final optimization model. So Xander's just going to explain a little bit more about our final optimization model and the 4 models that were included in that.
Thanks, Kate. So after we've written our optimizations mathematical model, we then proceeded to write the model into ample code. Now, some things about our ample code is that one, we decided not to use 2020 data. When we were looking through the transactional data, we realized that 2020 had a lot of missing data, which is probably tied to the pandemic. And so we wanted to have as much data as we could, so we used 2019 data as our base performance. We also chose weeks 46 through 51 to run our models because we wanted the Relocube tracker model to be able to be as accurate as possible. So it needed to be running for at least almost an entire year. So now what we then proceeded to do is we wanted to run the optimization model 4 different times to test what kind of different inputs would affect the outputs of our model. So the first time we ran our model, we wanted to use historic demand and historic supply data to compare it to the 2019 performance. When we use historic demand data, this is data that we got from SQL queries, and we use our historic supply data. We use our Relocube tracker model to see what the number of Relocubes to be expected to become empty in each week were. The second run of our model, we use the same historic data as the first run, but then we increased the initial inventory constraint by 10%. What we were interested in when we increased that initial inventory, we were interested in would it actually be helpful if ABF Freight just bought more Relocubes? Would that help minimize the costs? And then we also wanted to run the historical data as part of one of our runs because we need to see, does our optimization model actually improve the 2019 performance? So for the third run of our model, we wanted to use forecasted data. So for our demand parameter, we used forecasted origin demand And for our supply parameter, we used forecasted destination demand. Now, this is based on an assumption that forecasted destination demand will give us freed Relocubes at a completed transaction. We made this assumption by thinking that if a Relocube from the previous week arrives at a service center as a destination demand, then it should be freed up by that next week, because ABF Freight has a policy that any Relocubes that are unloaded, so they've gone to the final destination and become unloaded, ABF Freight has a policy that they have 3 days to unload the belongings and return the Relocube. And so for our fourth run of the model, we use the same forecasted data as a third run, but once again, we increased initial inventory. We really wanted to run these forecasted, we wanted to use forecasted inputs into our model because we were curious if we had an accurate enough forecast, would that actually be beneficial for ABF Freight? And would it really help them save costs by predicting what they should do? So next, Laura's going to talk a little bit about the potential impact our project could have for ABF Freight.
Yeah, thank you, Xander. So for the potential impact of our project, we used our performance measures, the empty Relocube utilization and the total empty miles allocated empty miles percentage that Joe mentioned before. And we wanted to compare these results to the 2019 performance, our base model. So for the empty Relocube utilization of our base model, we found there was 17%, and the total allocated empty miles percentage was 7%, as you can see on the screen. For our historical model, the empty Relocube utilization was 18%, and the total allocated empty miles percentage was 3%. And we found that comparing to our 2019 performance, we could reduce at least 65% of their cost, meaning that if ABF Freight does decide to implement this model into their system, they could greatly reduce their costs associated with that. Now, we do have to take into account that there may be other variables at play when this is implemented into the UPAC system. Now, moving on with our historical model with increased inventory, we found that the empty Relocube utilization was 16%, and the total allocated empty miles percentage was 2%, meaning that the cost decrease was 67%, just 2% more than our historical model. And this just meant that we can conclude that ABF Freight it may not be worth it to buy more Relocubes and increase their inventory, because by stakeholder interviews with Jacob and Kirby, we found that the cost of each Relocube is too high, and just a 2% decrease may not be worth it. Now, moving on with our forecasted demand model. Our empty Relocube utilization was 9%, and the total allocated empty miles percentage was 1%. And then we found that the cost decrease associated with that model was 81%, meaning that they do decide to implement the model and not use inventory, but just use forecasting data. And if that forecasting data is accurate enough, they could reduce 81% of their cost associated with that repositioning. Now, moving on to the forecasted model with increased inventory, both of the performance measures were the same as the forecasting model, and the cost decrease was just 1% more, just 82%. So the same as before, the cost of the Relocubes, it may too high, it may not be worth it to invest in more Relocubes. And yeah, so these are our results and the potential annual impact of the project. Now, moving on, Joe is gonna tell you more about how we can implement these 3 tools into the UPAC system.
So starting off with our Relocube tracker model, it successfully provides the status of Relocubes on a weekly basis between service centers. Currently, as it is in VBA, we have it split between 2 files because there's so much data, but by implementing the tracker in a different software, it would be a little bit faster for business purposes, such as like Java. And then also currently, if ABF Freight were to implement some sort of live tracking of the Relocubes, the data that would feed the Relocube tracker and also the optimization model would be a tad bit more accurate, which would make both of those be more accurate as well. Moving on to the actual forecasting tool, the forecasting tool successfully provides predicted demand or the optimization model. Currently, our tool does not include the geolocation of service centers, and the reason is to protect stakeholder interests of ABF Freight. But once this is supplied to them, it's best if they were to add the geolocation of service centers, that way that they could assess seasonality. And then lastly, we have our optimization model, which successfully which successfully minimizes the moves that goes with repositioning costs. One thing that we should really consider as far as like the optimization model, ABF Freight should consider adding their trailers to the optimization model. That way it would make their overall network a tad bit more accurate. And then as far as like our forecasting tool and optimization model, it provides 6 weeks worth of data with the mindset that ABF Freight can supply Relocubes within a week's notice of a customer's request. Those are the main concepts that we could do as far as like implementation. Next, Tate and Kate will cover the main takeaways of our presentation.
Thank you, Joseph. So just kind of to have a general recap, we started with the challenge that ABF Freight faced. That was the repositioning costs required to meet customer demand in high areas, having to move their equipment, move their Relocubes to meet customer demand before there's any value on board, leading to a loss for them. Moving forward, we using previous years of transactional data, we were able to generate demand predictions on a weekly basis for each of the service centers, each individual service center. And this just gave us a general idea of each service center's usage level. And also will give ABF Freight an idea of when and where and how many Relocubes need to be positioned at each service center throughout the year on a weekly basis, just due to that seasonality. Next, Kate's going to close it up.
Thanks. So we believe that our biggest contribution to this project is the optimization model that we created through the use of the Relocube tracker model and the forecasting tool. So this optimization model was built to minimize the repositioning costs incurred from empty miles traveled by Relocubes. And through the implementation of it, we believe that ABF Freight could greatly reduce empty costs caused by Relocube repositioning. Overall, our team feels very accomplished and grateful for the opportunity to work with ABF Freight. We thank you all for your time. This completes our final presentation. We are now open to comments and questions if you have them.